This lesson is on synthetic division and the remainder and factor theorem. Now, when we talk about synthetic division, first of all, we're talking about dividing polynomials. You may recall from past experience of using a long division process to divide polynomials. And we're going to start our lesson by reviewing that technique and then talking about how we can simplify that procedure under certain conditions and do this method called synthetic division. So let's look at that long division process first. This says to perform the following division. Now keep in mind, performing a division is different from reducing a fraction. So we're actually to do the division here. Now you might recall to do a long division process with polynomials, you put your divisor polynomial out here and do a division bar just like you did with numerical values. And then this polynomial here, which is the dividend, is going to be written under here. So let's write 3x cubed minus 10x squared plus 2x and plus 7. Now remember, one of the things that you always check for is to be sure that you've accounted for every power of x. Here in the dividend, we have x cubed, x squared, x to the first power, and then our constant. Remember, if you skip any of these powers of x, you have to insert a placeholder. Like if the x squared term was not there, you'd put a 0x squared in to save that place. And we'll talk about that again later in another example. Now, your division process starts out by dividing your x here into your 3x cubed here. So we know that x will divide into 3x cubed, 3x squared times. So let's put our 3x squared up here. And then remember, you multiply this 3x squared times both of these terms. 3x squared times x gives you 3x cubed. 3x squared times negative 2 is a negative 6x squared. Your next step is to subtract this from this. Remember, when you subtract, you change your signs and add. So I always encourage students here to change your signs. And then when we add these add to 0, which it should do. If it doesn't, we've divided wrong. This is 0. Negative 10x squared plus 6x squared is a negative 4x squared. And then we bring down that term. So let's bring down the plus 2x. Now we're ready to divide again. How many times does x divide into negative 4x squared? Well, it do what? Negative 4x, right? Negative 4x times x is negative 4x squared. Negative 4x times negative 2 is a positive 8x. Again, we're ready to subtract, so we're going to change these signs, positive and a negative. Again, these add to 0. Positive 2x minus 8x is a negative 6x. Bring down the plus 7. And then divide again. X will divide into negative 6x, negative 6 times. Multiply. Negative 6 times x is a negative 6x. Negative 6 times negative 2 is a positive 12. We're ready to subtract, so change our signs. This adds to 0, and 7 minus 12 is a negative 5. Now we can't divide anymore, so remember this is our remainder. Okay? Now, let's think about this process. Actually, what was important when we divided x into 3x cubed was our coefficients. 1 will divide into 3 times, right? And then notice this power is just 1 less than what we had started out here, okay? Now, when we multiply this 3, we multiplied times both of these. But since this is a 1, we got 3 again. This gave us our negative 6. Remember, it changed into a plus because we were ready to subtract, okay? Now, when we get this part right here, what's important? 1 into negative 4 is negative 4, right? So this is here, like the 3 was here. Again, the x just drops down a power from what we had here, okay? And then we multiplied times both of these, got negative 4 and positive 8, and then we changed signs, okay? These dropped out, we added here, got negative 6. Notice when we divided, because this is a 1, I got the negative 6 up here. Actually, in this long division process, our powers of x are not really that significant because what happens is we're just dropping down 1 every time. But these numbers here, the 3 appears here, the negative 4 appears here, and the negative 6 appears here. Why? Because this is a coefficient of 1 in front of that x. Now, I have a statement here about synthetic division. If the divisor is of the form x minus c, long division can be replaced with a more simple process called synthetic division. Now, divisor is x minus c. Our divisor was x minus 2. Does x minus 2 have this form? Yes, it does, doesn't it? So, because we're dividing by something that says x subtract a number, we can replace this long division process with synthetic division. Now, the best way to learn synthetic division is through example. So I'm not going to have necessarily a big long step here, but I am going to give you a little suggestion on how we're going to get started. To accomplish synthetic division, make c the divisor. Now let's talk about that c. Notice this says x subtract c. We're talking about c, what's being subtracted from x. That's going to be our divisor. What did we have subtracted from x here? 2. So 2 is going to be my divisor, so to speak here. Okay? List only the coefficients for the dividend. Now this is my dividend up here. It says list the coefficients. In other words, we're going to leave the x cubed, the x squared, and the x off. We're only going to list coefficients. Be sure to include the coefficient of 0 for any missing power of x in the dividend. Of course, this did not have a missing power, and so we're not going to have to do that. Now here's the key. Think about x minus c. We want to know what c is, and then we're going to list only coefficients of our dividend, leaving off the powers of x. When we list these coefficients, that it will include the sign. Now I have the same problem that we did just a while ago with this long division. You'll notice it's exactly the same problem. I'm asking you again to perform the division, but we're going to do it by this synthetic division process, and I'll show you how to do that very quickly and then how to read off the same answer that we have and the same remainder that we have. Okay, I want us to think again, x minus c. In our problem, we have an x minus c where c is 2. Okay, so we're going to make 2 the divisor. Okay, now with synthetic division, we actually usually set this up a little bit different. I'm going to put a little box sort of around that 2, and then over here we're going to list the coefficients. 3, negative 10, 2, and 7. Okay, now you can put the plus signs down if you want to, but they're not necessary. Now this is where this looks different. I'm going to draw a line down here underneath these coefficients. The first step is to bring down this first coefficient. So I'm simply going to bring down this 3 right here. Okay? Just bring that down. Then we're going to multiply. 2 times 3 is 6. We're going to put that 6 up here under this minus 10 above the line, and we're going to add these. Negative 10 plus 6 is negative 4. Okay? Multiply again. 2 times negative 4 is negative 8. Put that negative above the line. Add these together. We get negative 6. Multiply. 2 times negative 6 is negative 12. Put that up here. Add these. 7 minus 12 is a negative 5. Okay? Now, this process is real simple. What did we do? We figured out what c was and put it here. We brought our coefficients only down, and then here's what you have to remember. Bring the first one down, and then you're just multiplying and adding. Multiplying, adding. Multiplying, adding. Okay? So, looking at this thing, how in the world do we get our solution? Well, let me come back here. Look at your quotient. 3x squared minus 4x minus 6. Do you see these coefficients anywhere? They're right here, aren't they? 3, negative 4, negative 6. These numbers right here give me the coefficients of my solution. Now, here's how we're going to do this. These are the coefficients of my solution. What was the remainder a while ago? Negative 5. Do you see negative 5? Negative 5 is right here. The last number is always your remainder. Okay? So once you've completed this little multiplication and addition process, the last number is always your remainder. These other numbers will be the coefficients of the quotient. Now, to write the quotient, here's all you have to do. Write down this first coefficient. Look at your dividend. Whatever this first power is, reduce it by 1. So since this was x cubed, we're going to reduce that down to x squared. Bring down your next coefficient of negative 4, and you're just going to go down the line. If this is x squared, this is x. Bring down the next coefficient. If this is x, then there's no x value here. It'd be x to the 0 power if you want to think about that. Here is my quotient. And again, let's compare with the long division. Was my quotient 3x squared minus 4x minus 6? Yes, it was. Was my remainder negative 5? Yes, it was. Do you see how much easier, though, this process was to get that very same thing? Now, the thing to be sure about here is that you understand this synthetic division only works if your divisor looks like that. In other words, we cannot have a coefficient in front of x on our divisor. If this said 3x minus 2, then I can't do this process like this, okay? And the other thing is to remember it says x minus c. Now, we've seen that idea a little bit in some other lessons. If something says minus something, what if this said x plus 2? Then I've got to rewrite it to say x minus c to identify c, okay? Now, let's look at another problem. This says to find the quotient and remainder. Notice he's asking us to use synthetic division. So the first thing on synthetic division is think I've got to be dividing by x minus c. Does my divisor look like x minus c? Well, not exactly, because that says a plus sign, doesn't it? But how can you rewrite x plus 5 to say x minus something? X plus 5 is the same thing as what? X minus negative 5. Now these are equivalent, and so what is c? C is negative 5. Okay? It's very important that you get the correct c here. If c is negative 5, we're going to put that negative 5 down, put a little sort of box thing around it like that. We're going to list only the coefficients over here. See if you skip any powers of x. You don't, do you? X squared, x, constant. So I just need the positive 2, the positive 9, and the positive 1. Okay? Now draw you a line, leave some space, bring the first coefficient down, bring that 2 down. Multiply. Negative 5 times 2 is negative 10. Okay? Add those. 9 minus 10 is a negative 1, isn't it? Okay? Multiply again. Negative 5 times negative 1 is a positive 5. Okay? Add again. 5 plus 1 is 6. Now that's easy. What is this last number? That is my remainder. Okay? So this gives me the coefficients of my quotients. I'm going to write down that first coefficient. What power of x goes with this? Well, look at this dividend up here. Since it was x squared, I drop it down 1. This will be an x. And then bring down the minus 1. Okay, so here's my quotient. I have found the quotient and the remainder using this synthetic division process. That's much easier, isn't it, than that old long division process that you had? Again, the only drawback is it only works if your divisor says x minus c. So you've got to be careful about that. Find the quotient and remainder using synthetic division. Again, think about x minus c. Is my divisor of the form x minus c? Yes, it says x minus, what's c? It's 4. So c is 4. So we'll set this up with a 4. Coefficients of my dividend go here. Be careful on this one. Do you see what's happening? I have x cubed and I have x squared. Notice this doesn't have an x. What did I skip? I skipped x to the first power, didn't I? I don't have one of those. So I'm going to need to think about this as being 4x cubed, so we'll put down the 4, minus 17x squared, 0x's to the first power, and then that constant of 19. So I need this 0 here as a placeholder between the x squared and the constant term. Now I warn you, if you don't catch those and you don't put a 0 down, you're going to have an incorrect solution to your problem. So be sure and watch for that. Always do that mental check. Make sure you don't skip powers of x here. Okay, now what are we going to do? We're going to bring the 4 down, then we multiply. 4 times 4 is 16. Adding these, I get negative 1. Multiply, I get negative 4. Adding 0 and negative 4, I get negative 4. Multiply again. 4 times negative 4 is negative 16. 19 minus 16 is 3. Okay? Now, what's this last number? That's remainder, right? Okay, so what's my quotient going to be on this problem? Well, let's see. I'm going to start with a coefficient of 4. What power of x? Since this was x cubed, my quotient is going to start out with x squared, isn't it? Then I'm going to bring down the minus 1 coefficient. That'll be x to the first power, just going down the line, and then bring down the minus 4 as the constant. Okay? So our quotient is 4x squared minus x minus 4, and our remainder is 3. Okay? Now I want to show you something interesting here with this problem. Let's look at this numerator, this dividend polynomial right here. What if I just said this is a function of x, it's a polynomial in x? I'm going to write p of x equals 4x cubed minus 17x squared plus 19. That's a polynomial in x. Okay, and I'm just using sort of the function notation here. I want to evaluate this polynomial here at 4. Okay? Let's see what happens. Let's see. 4 cubed and then times 4 again, right? Well, let's think about that. If I have 4 times 4 cubed, let me move over here. You see what I'm doing? That's 4 to the 4th power, right? 4 4s multiplied together. Well, let's see. 4 times 4 is 16. Times another 4, that's 24. That's 64. Times another 4, that's what, 256, isn't it? So I have a 256 here, okay? And then if I put a 4 here, that's 16, okay? 16 times 17. Now this would be faster with a calculator. I don't happen to have one, so we'll do this the long way. 7 times 6 is 42. I'm carrying 4. 7 and 4 is 11. 6 and 1. So that's 272. Notice that'll be negative, minus 272. And then plus 19, right? Okay, how much is 256 minus 272? Well, it's going to be negative, right? Let's see, 272 and 256, I need the difference. 6 from 12 is 6. And I had to borrow, so 5 from 6 is 1. That's 16, isn't it? I have a negative 16 plus 19. Now, when I add negative 16 and 19, I get 3, don't I? I want you to notice something happened that's not necessarily a coincidence. Look at that remainder right there, and look at that value right there. What were we dividing by? We were dividing by 4. What did I put right here? 4. If I substituted 4 into this polynomial, what did I get? I got 3. What was my remainder? It was 3. Now, obviously, substituting that 4 in up here was a lot of work, wasn't it? Especially without a calculator. We had to do a lot of work to come up with that 3. Well, what I'm showing you here actually ends up being a very important theorem that will save us a lot of work sometimes. It's called the Remainder Theorem. Now, let's look at this. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Now, remember, to divide by something like this, what do? We put the c in front and we use the coefficients, right? That synthetic division process is easy, and it's easy to come up with that remainder. What he's telling me is that this remainder is always going to give me the value that I would get if I substituted this divisor into this original polynomial here. Okay, we're going to actually use this theorem in a minute to get us some quick answers. Now, while we're here on this remainder theorem, there's a second very important theorem called the Factor Theorem, and let's look at that. P of C is 0 if and only if x minus c is a factor of P of C. Now, let's think a minute about what it means for something to be a factor. If we have a factor, let's just do a real simple example. How do we know that 2 is a factor of 6? It's because when we divide 2 into 6, it does what? It divides evenly and gives us what? A remainder of 0. Okay? Now, if I take a synthetic division process, if I put C here and whatever my coefficients are, if my remainder ends up being 0, what is that saying? It's saying if I substitute C into my polynomial, I'm going to get 0. But if I get a 0 remainder, what does it also say? It says this divided evenly, and if it divides evenly, it is a factor. If it divides without a remainder, then it's a factor. We'll also be using this factor theorem to help us do some problems. Now, let's look at this next example that has to do with the remainder theorem. This says to use synthetic division and the remainder theorem to evaluate P of C. Now, here's this polynomial, okay? 5x to the fourth plus 30x cubed minus 40x squared plus 36x plus 14, okay? Now, if you want to, you could say this is my polynomial in x. This is P of x. So, to find P of C, where C is negative 7, what that means is substitute negative 7 for x. Well, now, if you think we had a hard time a while ago, think about doing this. If I take negative 7 to the fourth power times 5, negative 7 cubed times 30, negative 7 squared times negative 40, negative 7 times 36, and add 14, that's a lot of work. Even with a calculator, that would take a while. But what this allows me to do is to go back to this remainder theorem. If the polynomial is divided by x minus c, the remainder is the value P of c. Now this says c is negative 7. So what I want to do is put my c of negative 7 here. I'm going to list my coefficients. Now, do I skip any powers? 4, 3, 2, 1, no. So I don't skip any, so we just bring down those coefficients. 5, 30, negative 40, 36, and 14. And we're going to draw a line here. Now remember to bring the first one down. Negative 7 times 5 is negative 35, isn't it? When we add, what do we get? Negative 5. Negative 7 times negative 5 is a positive 35. Negative 40 plus 35 is a negative 5. Negative 7 times negative 5 is a positive 35, isn't it? Okay, well let's add here. I've got 6 and 5 is 11, 4 and 3 is 7. Now I need to multiply negative 7 times 71. Well, negative 7 times 1 is, that is a 7, 49, and that's negative, right? Okay, now I need to add these. I have opposite signs, so I'll get a negative. Find the difference here. 4 from 7 is a 3, 1 from 9 is 8. My remainder is negative 483. See how easy that was? What that tells me is that if I substitute negative 7 into this polynomial, I'm going to get negative 483. Now I could do that without a calculator, couldn't I? So what a neat way to get a value of a polynomial when it would be difficult to do it the long way. Now if you're not sure that I have done this right, you might want to get a calculator and check me and see if you don't get that same answer. But a very quick way to evaluate a polynomial at a certain value. Now we can even do this with fractions. Use synthetic division and the remainder theorem to evaluate P of C. Now again, here's my polynomial, and C is what? 2/3. So I want to put 2/3 as my divisor. And let's see, I don't skip powers, so let's list 3, 4, negative 2, and 1. Draw my line. Now what do? Bring 3 down. Now this is easy. What's 2/3 times 3? The 3's cancel, and I get a 2, don't I? Okay, 4 plus 2 is 6. Now if you need to look at this, what are you doing next? You're multiplying 2/3 times 6. What's going to happen? 3 cancels, 2 times 2 is 4. Negative 2 plus 4 is 2, right? Okay. 2 times 2/3 is 4/3. Okay. What's 1 plus 4/3? Well, 1 is 3/3, right? So I've got 7/3. Here's my remainder. So what does that tell me? If I put 2/3 into this polynomial, my answer is 7/3. So even with fractions, I can do this fairly quickly. Now in this next problem, we're asked to use the factor theorem. Use the factor theorem to show whether x minus c is a factor of the given polynomial. Now remember, if something is a factor, it divides evenly and the remainder is 0. So that's what we want to think about. Now here's my polynomial. My first part, part A, I have x minus 1. Now think about x minus c. What's my c on x minus 1? It's a 1, isn't it? So let's put a 1. Let's bring down these coefficients. Notice you don't skip any powers here. So I have 2, -1, 2, and -3. Draw your line, bring the 2 down. 1 times 2 is 2. Adding here, I get 1. 1 times 1 is 1. Adding, I get 3. 1 times 3 is 3. And adding, notice I get what? 0. My remainder is 0. So that says x minus 1 divides evenly with no remainder. So this is a factor. Okay? Now let's do the B part. Now be careful. X minus -3 is the same thing as x plus 3. So my c is a -3, isn't it? Let's put down our -3, 2, -1, 2, and -3. Okay? Bring down your 2. Multiplying, you get -6. Adding, we get a -7. Multiplying, it's a positive 21. Adding, I get 23. Multiplying, I get a -69. And adding here, I get a what? -72. This is my remainder. What does that tell you? My remainder was not 0. This does not divide evenly. So is x plus 3 a factor? No, it's not. Okay? So the whole key is something a factor basically comes down when you divide. Do you get a remainder of 0 or not? Okay? Now I have one other example I want to do using this factor theorem a little bit. Given a polynomial 2x cubed plus 11x squared minus 7x minus 6. It says to show that p of 1 is 0. Okay? If I substitute 1 in, I get 0. Now you could, since it's a 1, if you want to, you could just put in a 1. But remember, another way to look at that is to say, okay, if I put a 1 here, 2x cubed, 11x squared, negative 7x minus 6. Okay. Synthetic division, let's pull that 2 down. 1 times 2 is a 2. Adding, I get 13. 1 times 13 is 13. When I add here, I get a positive 6. 1 times 6 is 6. When I add, I get 0. So if I put a 1 into this polynomial, I get a 0 answer. Okay? Now, p of 1 is 0. Use this to find all factors and all zeros. Now, let's talk about factors first. If I divide here and I get a 0 remainder, it says what? Something was a factor. Remember, this 1 right here is c, isn't it? What was I dividing by? I was dividing by x minus c, or in other words, x minus 1. X minus 1 is a factor of this polynomial. Now, let's look at my quotient. I know my remainder is 0. My quotient would be 2x squared plus 13x plus 6, wouldn't it? We're saying when we divide x minus 1 into this polynomial, we get this quotient with a 0 remainder. Okay? Think about this. If I divide 2 into 6, I get 3 with a remainder of 0. And what does that mean? 2 times 3, the divisor times the quotient is equal to the dividend. So x minus 1 times 2x squared plus 13x plus 6 is equal to this original polynomial. But it's factored a little bit. Now, having this first factor will allow me to completely factor, to find all factors. Look at this. I can just do my old factoring. To get 2x squared, I have to have 2x times 1x. Same signs. Both are positive. Let's see, we're trying to get 16 using factors of, trying to get 13 using factors of 6. Well, let's see if I put a 6 here and a 1 here. 12 plus 1 is 13. That's it, isn't it? So here are all of the factors of this polynomial. X minus 1 times 2x plus 1 times x plus 6. Okay? Now, what does he mean by finding all zeros? What that means is, if I take this polynomial, 2x cubed plus 11x squared minus 7x minus 6, and I set it equal to 0, what are the x values that will give me that? Now, since I know this factors into this, the product of these factors must be 0, right? And then what does that allow me to do? Set each factor equal to 0, doesn't it? X minus 1 equals 0, 2x plus 1 equals 0, and x plus 6 equals 0. Now let's solve for x. X equals 1, 2x equals negative 1, so x is negative 1/2, and x equals negative 6. These are my zeros, as we call them. These are the x values that will make this polynomial equal to 0. Notice here we've already shown that if I put in a 1, I get 0. And so these also will give us a 0. Okay? So what we've done here, if we can find a 0, putting this in the form of x minus c gives us a factor. The quotient gives us another factor. And then if this is quadratic, very often we can factor again and get all of the factors. Once we have all of the factors, we can find all of the zeros. Now, this last example went through several things that you'll get more reinforcement about as you go into other lessons. In college algebra, you'll talk more about this idea of finding a 0 and getting all the factors. But this just gets you started and it lets you see how you can use synthetic division. Now again, the important thing on when can you use synthetic division, your divisor has to be 1 times x minus c. So you've got to be able to identify the c, get the correct c value. And then remember, you put down only coefficients and be sure to watch for any power of x that is omitted. If you don't have a power of x there that you need, you have to put in a 0 for that. And then that process of bringing down that first coefficient, multiply, add. That last number is your remainder. Those other numbers gives you coefficients of your quotient. I hope that through this lesson you've learned about synthetic division and you understand how this process works. Thank you.